Xylems are non-living conducting tissues. They conduct water and dissolved salts from root to different parts of plant. Xylem also forms esodan plants. It supports plant body. Xylem tissues are present only in tracheophytes. Composition of xylem. Xylem is composed of phloem types of tissues only in tracheophytes. Composition of xylem. Xylem is composed of phloem types of tissues. Tertiary elements. The specialized water anti-salt conducting cells of xylem are called tertiary elements. The cells are elongated and linified. They have thick secondary wall with various types of pits. These cells are non-living at maturity. Tracheal elements are of two types: sad phase A vessel members. The tertiary elements which are short, wide and with perforated end walls are called vessel members. The vessel members are united end to form long xylem vessels. The length of xylem vessels is variable in different plants. It varies from 2 to 15 e. Perforated end plates of vessels are called perforation plates. The perforation plates are simple or multiple. Simple plates have only single aperture. Multiple plates mean many apertures. Different vessels are connected to each other through pitted walls. Water and move through these pitted walls from one vessel to other. The secondary walls of vessels have different thickness. These may have annular, ringed, spiral, scalariform wool reticulate. These thicknesses are found in newly formed xylem. The vessels of mature xylem have uniform weights. Vessels are present only in dicot angiosperms. Tracheates, the tertiary elements which are elongated tube-like with tapering ends are called tracheates. They lack perforated plates in the end wall. Water moves from one tracheate to adjacent tracheates through pit membranes. Tracheates are present in all the vascular plants. The mature tracheates have characteristic thickenings like annular, spiral, reticulate and pitted. The two adjacent tracheates have bordered pits in the common wall, but the tracheal walls have simple pits. 2. Fibers. Fibers commonly occur in xylem. The fibers are elongated thick one structures. They perform the supporting functions. Fibers have thick wall. Mature fibers are dead cells. The fibers in the xylem are divided into two types: sad phase A fiber tracheates. These are like tracheates, but they have pratishat cry thick wall. These walls have some remnant of bordered pit. B libriform tracheates. These fibers are narrower. They have remnant of simple pits in their pratishat areas. Parenchyma. Parenchyma is present in both primary and secondary xylems. They form vertical rows in primary xylem. They are parallel to tertiary elements. Parenchymal cells are present in both vertical rims and transverse rows in secondary xylem. The xylem parenchymal cells are living. They retain protoplast. The parenchyma cells store food in the form of stalk. The wall of parenchyma cells may remain thin. Sometimes, they develop secondary wall with simple pits. The amount of parenchyma determines the softness and hardness of wood. Soft wood has a large number of parenchyma. Hard wood have thin joda parenchyma. Old tracheal elements become will net ional the contents of the adjacent parenchyma integrate into the tracheal elements through pits forming tylosis. Types of xylem. There are two types of xylems. Primary xylem. The xylem produced as a result of primary growth are called primary xylem. The xylem components are arranged vertically only in prim Y xylem. In this case, xylem elements are arranged two parallel axes of plant and plant form the axial system. Primary items are produced procambium during primary growth. There are two forms of primary xylems. Protoxylem. The early primary xylems are called protoxylem. Protoxylem appears at the beginning of differentiation. Protoxylem mostly becomes mature before elongation phase. They have annular and spiral thickenings. Protoxylems have few tertiary elements, but they have a large amount of parenchyma cells. They are mostly present near the pith in stern. In root, they are present away from center. Metaxylem. The xylems appear later during differentiation are called metaxylem. Metaxylem matures after elongation phase. Metaxylem has spiral, reticulate and pitted walls. Metaxylems are composed of tracheates, vessel, parenchyma and fibers. Metaxylems remains functional only in plants in which secondary growth does not occur, grasses. In other plants they become non-functional. Secondary xylem. The xylems which are produced as a result of secondary growth are called secondary xylem. Secondary xylems are reproduced by the activity of cambium. They are found in only those plants in which secondary growth occurs. Secondary xylems form axial system and ray systems. Secondary xylems are composed of two types of systems: shocked face, axial or vertical systems. In this case, xylem elements are present parallel to vertical axis. They mostly compose of dead trachary elements, trachyte in vessels, fibers and parenchyma, or radial or transverse system. This system is composed of parenchyma cells only. Their long axes are at right angles to the long axis of organs. They form xylem rays. They are mostly composed of living cell. Phloem are living conducting tissues. They conduct prepared food from levers to different part of the plant. They are also involved in storage of food and mechanical support. Components of phloem. Phloem is composed of sieve elements, companion cells, phloem parenchyma and phloem letters I. Sieve elements. The elongated cells with characteristic sievaries in their walls are called sieve elements. Sieve areas are calmed by modified pits. The protoplasts of the adjoining cells are continuous pores of sieve areas. These elements have primary thin walls. The sieve are rich of pores cytoplasmic connecting strands. These strands may be thin like plasmodesmata. These strands are surrounded in close carbohydrate. Thicker loose layer becomes thick in mature sieve elements. The cados completely closes the dormant sieve elements like a pad. The close disappears from theatrical sieve elements. Some ZA elements are oblique. Such sieve elements have sesquipedal prominent areas. Some sieve elements bind trans, to end walls. Such sieve elements only single sequera with large pores. The sieve elements are divided into sieve tube members and sieve cells. Point 1. Sieve cells. The sieve areas are not specialized in sieve cells. These areas are not restricted to some specific part of the wall of the cell. The sieve cells are arranged in longitudinal files. The sieve areas are present mostly in the adjacent walls of the sieve cells. The phloem of gymnosperms and lower vascular plants contain sieve cell only. Point 2. Sieve tube members. Sieve areas are well developed in sieve tuber members. Sieve areas are confined only to end walls of cells. They form sieve plates at end walls. The sieve tube members join and tend to form long tubes called sieve tubes. The phloem of angiosperms is composed of mainly sieve tube members. Companion cells. The thin-walled parenchyma cells closely associated with the sieve elements are called companion cells. Companion cells cut off from T cells initial which later form sieve element. Companion cells are living. They are physiologically active. They have a prominent nucleus. The CS tubulement and companion cell have close contact. Companion cells are absent in gymnosperms and looser vascular plants. But certain parenchyma cells called albuminous cells are closely associated with sieve elements in these plants. These albuminous cells are similar to the companion cells in their function. Sclerenchymatous fibers are commonly abundant in both primary and secondary phloem. The fibers occupy the outer portion in the primary phloem. They are used as commercial fibers, e.g., hibiscus. Phloem fibers are elongated. They have thick secondary wall. They may be living ordered at maturity. The phloem fibers may be septate in certain cases. The phloem pratishat are called bast due to presence of these fibers. The thick soil of fibers is not linified. It is composed of only cellulose. The fibers are also arranged axially, vertically, in secondary phloems. Parenchyma. Small parenchymas are present in both primary and secondary phloems. These parenchyma cells are arranged vertically in primary phloem, but these are arranged venically and radially in secondary phloem. These cells become thick wall in older portion of phloem and change into sclerenchyma cells. Phloem parenchyma cells are thin-walled. They are living and physiologically active. They store different compounds like starch, tannins, and different crystals. Types of phloem. Phloems may be primary or secondary. Primary phloem. The phloem fund is a result of primary growth is called primary phloem. Primary phloem is initiated in the embryo. It develops monocambium. Primary phloem has two types. Protophlome. Protophlome is composed of elongated sieve elements only. They lack companion cells. Sieve tube elements lack nucleus, so they remain active only for a short time. They soon disappear. Point 2. Metaphlome. Metaphlome mature later than protophlome, so they remain active for longer time. Secondary growth does not occur in monocot plants, so they remain active in secondary phloem. The phloem formed as a result of secondary growth is called secondary phloem. It has two types. Vertical system. Vertical system is composed of sieve elements, companion cells, phloem fibers and phloem parenchyma. Ray system. Ray system is composed of ray parenchyma only.